So chapter 1 is just an introduction to how computers work and how programs work. We're not going to be learning how to write any code in this chapter. This is just an overview of how computers work. The book that I've chosen has some videos that come along with it. The author of the book is a professor that recorded his own videos. So in every lecture slide, you will find a link to those videos in case you want to watch them as an extra resource. So to start off, let's think about why were computers built? Why did the first people that build computers build them? Well, the reason is they wanted them to operate and automate some of the tasks that we do. So instead of us doing a task over and over again, computers can help us automate those tasks. And so when we want the computer to do something, how do we make the computer do that? Well, we need to write some program, and we need to be able to do that in the computer language. So if you want the computer to do something, you need to be able to talk computer language in order for them to do that task. And so you as a programmer will be talking that computer language. You will be able to design, create, and test computer programs. So when you start writing a program, you don't just sit at the computer and start typing. You have to think a little. So you will go through a design phase where you're thinking about, how am I going to write this program? What am I going to do first? What am I going to be testing to make sure that the program works and doesn't break? Then you'll be writing your program, creating it, and then you'll be writing some tests to make sure that your program works correctly. Another name for a programmer is a software developer, and the programmer or the software developer writes a program, and basically a program is a set of instructions that you are giving the computer to follow. So for example, if you are writing a program to calculate how much someone should get paid at the end of the month, you should say, okay, well, the first thing I need to know is how many hours this person worked. And the second thing I need to know is what is the hourly rate for this person. And then after I get these two pieces of information, I need to multiply their hourly rate by their hours to know how much I should pay them. So these are a sequence of instructions that you will be telling the computer to follow. You can't just tell the computer, calculate the wage, and they will be able to do it. So you have to give specific instructions. The program, how do we get a program onto our computer? Well, using some software. So when you install software in your computer, when you install PowerPoint, when you install Chrome, when you install any software, a game that you're playing on the computer, you are actually installing a program that is telling the computer what to do. So imagine playing a racing game that you've installed. Well, the racing game has instructions built into it that tell it when I click the space bar, I need to pause. When I click the up arrow, the car needs to move up. So this is a program. It's instructions that are given to the computer so the computer knows what to do. So this is software. Well, what is hardware? Hardware is what is inside the computer, and some of it we see and some of it is outside the computer. Some of it is inside the computer and we don't see, and some of it is outside the computer and we see. So first, let's start talking about the hardware that's inside your computer. So the computer inside has a motherboard. This motherboard has something called the central processing unit, the CPU, and the CPU is basically the brain of the computer. It manages everything. It tells the computer what to do. Now, for this brain to operate, it needs to store information somewhere. So there are two pieces of information, pieces of memory that the computer uses. There is main memory and secondary memory. And at this point, I want you to pause and think about which is main memory and which is secondary memory. So when you're going to buy a computer, you always want to see how big the hard drive is. Is it, 500 gigabytes? Is it a terabyte? And then you also want to look at the RAM, the random access memory of the computer. So these are the two types of memory, the hard drive, for example, and RAM. So think about it. Which one is secondary memory and which one is main memory? And we'll mention it in a little bit. And then in addition, you have some input and output devices connected to your computer. So like I said, the CPU is the central processing unit. It is the brain of the computer. Input and output devices help the computer gather information and give back information out to the user. So if you want to tell the computer you're playing a game and you want to tell the computer to click somewhere, well, you need a mouse. If you are typing your essay and you want to put your essay inside the computer and save it on your hard drive, you need a keyboard. So the keyboard, the mouse, the scanner, we use these devices, these hardware devices, to put information into the computer. They are called input devices because they take information from the user and put them into the computer. On the other hand, when I want to get information out of my computer, I need an output device. I want to see the video that's on YouTube, okay? I need a monitor screen to do that. I want to hear the voice in my video. Well, I need speakers or headphones to do that. I want to get a printout of my essay that's saved on the hard drive. I need a printer for that. So these are called output devices. They show you what's inside the computer. So input are used for putting information into the computer and saving it onto the computer. Output devices help us get information outside of the computer, out to the real world. And like I said, there is something called main memory and secondary memory. So main memory is actually fast memory, temporary memory. It's the RAM. It's the random access memory. This is where the computer will store the program that is being run. So right now, when you want to go and buy a computer and you look at RAM sizes, you might find 2 gigs of RAM, 4 gigs of RAM, 8 gigs of RAM, 12, 16, 32. And of course, the higher the RAM, the more expensive the computer is. Right now, about 8 gigs of RAM is reasonable to get. Anything less than that will be slow. The more software that you run on your computer simultaneously, the more RAM you will need. So if you're going to be developing code and playing games and all that, you'll need at least 8 and maybe even 12 gigs of RAM. One thing about RAM is that it's temporary storage. So anything that's stored in RAM, it's storing what's running right now on your computer. So if I opened up YouTube and my PowerPoint on a website that I'm looking at, all these programs are saving their temporary information in RAM. Once I reboot my computer or I turn off my computer, everything that is in RAM goes away. So this is nice in the sense that if your computer is running slow and it's running out of RAM, what you can do to clear out the RAM is shut down your computer and just restart it. That will clear out the RAM. Now, secondary storage is a little bit slower and it is permanent storage. Okay, it lasts until it's deleted. If you write an essay, you want it to go to your hard drive or your flash drive, and you want it to stay there until you decide when to delete it. You don't want it to get deleted when you turn off your computer. So this is called storage, secondary storage. And some examples are like, your hard drive, your USB drive, a DVD drive. These are all examples of secondary storage. Right now in the market, about 1 terabyte is a good size for your secondary storage. The other thing I want to talk about is how do computers store information? So computers don't understand letters and numbers. So when you're typing your essay and you're typing your name at the beginning of the essay, you're typing, the letters A, B, C, D. How are these letters getting stored on the hard drive, for example? Well, the hard drive only understands signals, or computers in general only understand signals. And so they understand if a signal is on or a signal is off. There is a signal or no signal. So if there is a signal, we say that we call that a 1. So like I said, computers only understand signals. And a signal can be on or off. There is a signal or no signal. And so the way we indicate this is by saying a signal is represented as a 1 and no signal is represented as a 0. And so when we say things, how are things stored on the computer, we say they are stored as signals, 1 or 0. So we call 1 and we call 0, we call these bits. And to represent any letter, any character on the keyboard, we need a sequence of 8 bits. So 8 bits together I think I have an extra one. That's called a byte. Now, the byte is the space in RAM. So if we think about RAM, we said RAM, when we go look at RAM, we say, for example, 4 gigabytes. Okay. So what we're saying, first of all, let's think of a byte. So a byte is just one storage, okay, and it can hold 8 little bits, ones and zeros. If I say 1 kilobyte, that's about 1,000 bytes. So now I'm talking about RAM space that's capable of holding 1,000 locations, 1,000 letters, 1,000 characters. When we talk about 1 megabyte, that is about 1,000,000 bytes. Okay, so now we're talking about RAM space or a hard drive that can handle 1,000,000 characters. When we say 1 gigabyte, we're talking about 1 billion bytes. And if we talk about a terabyte, you're going to multiply that by 1,000. So RAM or the hard drive is broken down into little chunks of memory. Each space in memory is capable of storing 1 byte, which is able to store just the character, like the letter 8, for example. And so this is called the binary numbering system. So if we look here at this table, it's called the ASCII table, and it's telling us how every character is stored. So if I look at the letter A, for example, it is will be stored on the computer in storage as 1000001. Lowercase a, on the other hand, is stored as 11000001. Okay. Now, these numbers are hard to say. So what we do is we translate them into decimals. So we say that A, lowercase a, is stored as the number 97, and uppercase a is stored as the number 65. Now, you don't need to remember any of this. You don't need to memorize any of this. This is just an overview of how the computer saves information. So now the computer is talking a language of signals. It's only understanding bits and bytes, zeros and ones. We call this machine language. Now imagine if you had to write a program in machine language. This would be horrible. So we do not write code in machine language. We write code in a high-level language, a language that you as a programmer will be able to understand and memorize. Python is a high-level language. There are a lot of high-level languages out there: Python, C, C++, Java, PHP, a lot of languages. These are high-level languages. So how does information, or how does a high-level a program written in a high-level language such as Python gets translated into machine language so that the computer can actually understand what to do? Well, the way we do that is using something called a compiler or an interpreter, and I will talk about that in the next slide. The first thing I want to mention here is that when you write your code, you're going to be writing it in kind of plain English, like we said, in a high-level language. The file that you write your code in, this will be called your source code or your source file. So when I ask you to show me your source code, I'm asking you to show me the code that you wrote, which is a high-level language code. When you write this code, you need to make sure that it will be able to be translated into machine language. And so if you have any errors in your code that prevent it from getting translated into machine language, the interpreter in Python will complain, and it will complain that you have something called a syntax error. So a syntax error, you can think of it as a punctuation error, for example, for now. We will see examples of that later during the semester. But a syntax error happens when you make a mistake as a programmer, which prevents your high-level code from being translated into machine language. And so to translate this code into machine language, there is something called a compiler, and there is something called an interpreter. Now, Python does not use the compiler, so I'm just going to skip over that for now. Just know that if you're doing something like Java, if you've learned Java or C, you've used a compiler. But what we're doing when we're using Python is using something called an interpreter. Now, the difference between a compiler and an interpreter is that a compiler will look at your source code, every single line of source code, and if it's okay, if it doesn't have any syntax errors, it will translate it into machine code, and then it will start giving you an output. Now, if you have any problems with your code, like you wrote 100 lines of code and line 99 is the one that has a problem, your code will never run when you're running with a compiler, with a compiled language like Java or C or C++. With an interpreter, you have your source code, and the interpreter will go through your code line by line, translating it into machine language and outputting it. So if you have 10 lines of code and line 10 has an issue or a problem, it's okay. Your code, the first 9 lines of code will get run. So in some sense, an interpreter is nicer, an interpreted language is nicer in that you might have code that has problems, but at least you can get some output out of it before it breaks down. With a compiler, you will be able to find all the mistakes in your code before anything is run. So that also has its advantages. Now, what I want to show you now is 2 things that you will need to install for this class. I want you to get them installed on your machine before next class, because next class we'll be starting to write code. So we need Python, we need the Python interpreter, and there's another piece of software called Mu, which is an IDE, an integrated development environment, which helps us write code in a user-friendly way. So to download Python, you're going to go to python.org, and you're going to find whatever the latest version is, and you're going to install that. Okay. When you're going through the installation, you will click on the install now. You will make sure that you check the check boxes, and you will go and continue with the installation. Once you've installed Python, I want you to install Mu, and the way you install it is you're going to go to codewith.mu. And you're going to select your operating system and install the software. And next class, we will actually be using the software to write some code. If you run into any issues installing either Python or Mu, please take a screenshot of your error and email me so that I can help you get it installed before next class.